Today is a repair video and we're going to be taking a look at a faulty VRX unit for HDZero Shark Bite. A user posted on Facebook that his module was dead and he was based in the UK, so I said to him, send it over to me and we will take a look. In this video, I'm going to walk you through what we did to diagnose the problem, what we did to repair it, and then at the end, I'm going to share with you my thoughts. Now, just before we jump into this, I just want to say, if you find this video useful, please do consider giving it a like. If you're not a subscriber already, please do consider hitting the button. Also, if you'd like to support us to keep making content like this, please do check out the links to my Patreon in the description. Anyway, let's get on with it. Let's take a closer look at what's going on with this module. So, the first thing we're going to do is some basic tests. We're going to test it with a proper HDZero power cable. We'll do it on my one first of all. So what I've got is a 4S LiPo with the proper cable. This has a built-in regulator, which takes it down to about 7.8 volts. And then I've got a short saver in place. So just to demonstrate that that is working, that's my module there. You can see it all kicks in. We've got an LED on the top and everything looks correct. What we'll do is put mine to the side and we will plug this one in. We'll turn it on, just to show you the lights on, and nothing, no signs of life at all. No flickers of LEDs. No sign of shorts, because if there was a short, this would kick out straight away, but it's clear that we've got no power on the module at all. So we're going to need to strip it down and have a look what's going on. But before I do that, I'm going to do the sniff test. Now, what the sniff test is the smell for magic smoke. So let me just have a smell. There is a slight whiff, but nothing phenomenal. Might be normal module smell. Let me just smell mine. Mine's a bit more inert. There's definitely a whiff there on this one. Anyway, what we're going to do is get this apart. So we've got our two patch antennas on the front, so we want to take them off first of all. Now these unclip, so what we can do is very gently give these a bit of a pry, and these front antennas will pop off. There we go. That pops the cover off, and you can see we've got the antenna there with the cable pointing through. We're going to do the same on this side over here. Pop him off. Take him off as well and pop that out the side, and you can then see that leaves our board and we can see through. What we'll do then is carefully unclip these and take these off the main PCB. Removing them vertically so we know we've got them out of the way. We'll then flip it over to the other side, and we've then got 4 screws that we simply need to remove to get into the back of the main module itself and get the back cover off. Now, the explanation from the user on this one was that it was working fine. They bought it used, I believe, and it was working fine. They started having some other issues, and then they lost all power and it wasn't working at all. So what we'll do now is give that a bit of a gentle pry. I've got a pry tool there. If we just gently give a bit of a lift by here, the plastic casing will start to open up. You should really use a plastic pry tool for this. Gently go around the back. There we go. And we can lift the back cover off. Place that there. And then we can see in the module. Taking a bit of a quick visual inspection, not seeing anything untoward instantly. Switch was in the down position. I'm going to put that back in the up. The user did try to update the firmware, so that might be the reason that was there. But so far, nothing looks out of place. So what we need to do now is get the boards out and have a look if there's anything really sticking out and anything showing up that we wouldn't expect to see in a working module. So what we'll do is start to get this board out. Now there is a connector between the top and the bottom board on this. It's located down in there. So what I'm going to do is just gently pop that in backwards, give a bit of a pry. There we go. That will release that. Now we have to be careful because that is sticking through there. So the best way to do this is gently lift up at the side, try to get a grip on it, and what you want to do is gently try to rotate it out as we lift, but without bending. We've got a board here as well at the back, which we can push forward. There we go. And then we simply need to unplug the fan that's located down here, out of the way. And then you can see that we've got both boards of the system out. Now, there's two parts to this. We've got our sort of front-end RF HDZero board, and then we've got our back-end board, which is more the video side of things and the HDMI. We can see you've got our power input here. We've got our HDMI, our SD card, as well as our adjustment here for the settings. So what we'll do now is get in a bit closer and do a visual inspection and see if we can see anything untoward before we do some tests. So what we'll do is we'll just take off these pads and gently place these over here out the way, just to give us a bit more visibility of the PCB. These are heat transfer pads. Take them off nicely. So we've got our DC in. We've got our other components. So let's have a look there. So far, everything looks good. I'm not seeing anything burnt. I'm not seeing any signs of water or anything like that. Flipping the board over to the other side. That all looks fine. Let's just take a quick look at the RF board before we pop it all under the microscope, just to see if there's anything, again, looking crazy. No, everything here looks good. Popping it to the other side. Certainly not seeing anything untoward. So let's get it under the microscope and let's just have a closer look to see if anything sticks out visually first. Starting in the bottom left corner by our DC jack, what we'll do is we'll have a look around here. We've got that there, which is probably a fuse. We've got some capacitors. Let's just work our way around the board. That's the back of the SD card. Actually, no, sorry, that's the back of the lever. That all looks fine. Top of the board. So if we just go along, have a look at the connector. That all looks good. Right over to the other side. Yeah, that's all fine. What we're just looking for is any signs of anything burnt out. And then if we can't find anything, we'll start doing some testing on the input and having a look there. No, that all looks fine. The field of view you have got here is a bit smaller than what I'm looking at through the actual microscope. So I've got a bit of a wider view I can see. So, no, not seeing anything there. If we flip it over to the other side, right down now by the power jack, that looks fine. We've got a diode there on the input, so we want to be checking him. It's the kind of thing we want to be looking for. Looking around. That all looks good. I'm not seeing anything on this board that concerns me. What's interesting here, let me just flip that around to show you if you haven't seen, there's actually a UART built into this over here. This is where you would connect the backpack functionality for Express LRS if you wanted to do that. We may check that out in a future video. But I'll be honest, looking around, I'm not seeing anything at all. What we'll just quickly do is have a look at the second board. I'm going to do this quickly as a visual one under the microscope. Again, we're looking at the top end up here. We've got our RF end. So you can see we've got our filter there on the RF. We've got our baseband chip, our filter heading out towards the antennas on the SMAs. Scrolling along. That all looks fine. No signs of anything burnt out. No, that all looks to me absolutely perfect. As I've mentioned, everything looks good. So we're now at the stage where we need to do some testing. We're not going to be doing too much on this. There's not a lot here we can test on this because that really is the RF board. There's not a dramatic amount on that other than there being physically burnt out components we can do. But as this appears to be a power issue, the chances are the issue will be around the input or the regulation circuit or things like that. So if we get in as close as I can on the overhead. What we can start doing is having a look at the circuit. Now, on that back side, I did see a diode, which I want to check in a minute, because I always look for things like diodes might be shorted to ground, although we're not seeing a short on the input, but it is worth checking. We've got some power regulation here. You can see we've got a buck converter because there's a coil. There's another one here. There's another one here. So there's plenty of areas we can start looking at with regards to the power. There's another one over here. You can see we've got another coil. So there's lots of different stages of voltage regulation going on. But what we'll do first of all is look at some of the basics. So we will just check if there is a short on the input of the module. I'm not expecting there to be, because it did look okay. But what we'll do is we will check ground, which is that there, and we will check it to the input there. And that's fine. There's no beeps. There's no noise. We're on diode mode, so there would be a beep there if there was a short. What I'm going to do next is hop over to this side. I'm going to just take a look at this little diode here. Because it's on this side, I just want to see what the score with this one is, whether there is anything going on with it. Just looking at my meter, getting a reading that way, swap it round. That looks fine. No reading that way. Yeah, that's fine. I'm getting readings on that diode. Absolutely no problems at all. So if we now start looking at where the power input comes, we've got our shielding goes to here on the earth side. And then we've got a pin that comes down the side. And we've got here, power input comes here. So if we just check our center pin to there, should be there. Yep, perfect. And then if we have a look here, it seems to come through here and through what appears to be a fuse. It doesn't look like a 1 ohm resistor. Let's do a test on that first. We've got power here. Oh, okay. Oh, okay. So there's nothing there. So we got power off the center pin to there. Nothing there. Now this, it looks like a fuse. Let's just put that under the microscope and have a look at a closer look at that directly. Okay, so if we just get in a bit closer and do another test, we are open circuit on that. Now this is labeled N. It's green. My belief is that would be a fuse. It's the kind of device I've seen in the past which would be a fuse. Looking at the circuit, you can see here it comes out the back, the center pin to here, into this track here, which is isolated. That just goes through the other side of the board, but there's no tracks off that. I've checked that already. That then jumps over to here, which goes all the way along up to here, and then up to this little regulator over here. So if this is the voltage input, what I would expect is this to be the positive side of the capacitors and these to be grounded. So one nice easy check we can do is we'll go off the top of the can here. We'll go here. Yeah. So that's the ground side. So this should be the positive input. So what I would say at this moment in time is that this fuse is blown. The next question we need to just check before we do anything else is to check that there isn't a short on this side of the fuse and this side of the fuse. So if we go there, that's fine. If we go this side, open circuit, absolutely fine. No short there at all. Going on to down there. That's cool. So at this moment in time, it just looks like the fuse is open circuit. So what we'll do is we'll get that off the board. I'm going to have a look at what I've got. I don't really want to jumper wire it. I should have a board with a fuse on here. So let's go and have a look. But let's get this off first of all. I think I'll do this with the iron. I'll put some flux on and we'll lift it with the iron first of all and get it off. So looking over boards to try and find a fuse, I've got this MacBook board which we've got here. There is a big fuse up here on the power input. That's labeled 12. My bet would be that's probably a 12 amp fuse. I don't know what that one is rated at. That's a little bit higher than I would like. There is, though, another fuse on this, which is a backlight fuse, which is located here, labelled P. But that one is a little bit smaller than what we had on it. So I think we're going to end up going with this big one up here a minute. So what I think we'll do is we'll get this off with hot air rather than using the soldering iron. Just so we can get it off the board properly. And I think we'll try that one and go from there. Now, rather than do this one with hot air, I'm going to do this by hand, simply because it's quite a tight area. There's some plastics around it. I don't really want to risk damaging anything else that's there near it. So rather than do that, we're going to go in and do this one manually by hand. I might flow it in a minute just to get it flatter to the board, because we are held up off just now, but I'm not particularly concerned a minute. I just don't want to put too much heat in this area. So what we'll now do is just check that we still now have continuity before we clean this up. So if we just again come down to here, what we're looking for is continuity. Here we go. I'll clean all the flux off in a minute. So now we've got continuity through from there to there. No sign of shorts on the top of the board. So hopefully that's all good. So what I'll do now, first of all, is just clean that all off. And what I might do is just settle that with a little bit of air, smaller nozzle, just to make sure we get it in just right. Okay, so now looking under there, you can see the fuse looks absolutely perfect. Just a bit of heat just to get it to sit flat on the board. So what we'll now do is get it all tidied up. There's a couple of other bits I just want to touch up here around this knob. This is very, very delicate, so I want to be looking at that, but we'll hop over to the other camera for that one. So from here, it all looks much better. Now, I just want to check this because there's been a bit of movement on this, which is worrying me ever so slightly, and I'm just trying to understand. There's some connectors on the side that appear to have broke free, so I'm just gonna tidy them up with the iron very, very quickly, just to make sure that's holding on. So what we're going to do is we'll use a bit of tape to hold it in place, so we'll do that next. Okay, so everything's cooled. What we'll do now is a bench assembly and power up and see what happens. So the first thing we need to do is take the unit itself. Now, these two boards go side to side, but what we need to be careful of is there was the pads on here to stop things touching. So we do need to make sure that we put them back in place, because what we don't want is anything to start shorting anything else out. So we do have these nice isolation pads. We had one there, one on the HDMI, then there was another one on top of that there. Good. So we'll then put the boards together. There we go. It's the two PCB sandwiched, and we can then see that, yep, that's fine, that's fine. It's all looking good. We will then plug in our fan as well, just to make sure that we do have that, so we can see what is going on with the cooling side of things. what we can do then is gently drop the unit back into its housing. I'll just pop it in there. I'm not going to push it in too far, just in case we need to get it out. We've got no antennas on a moment, so now's the moment of truth. We will again take our battery. We've got our short saver, so we'll get that in view. We're going to be looking for our DC jack. We can't, so what we're going to have to do is just pop that back out so we can actually get to the DC jack. There we are. Sorted. So what we'll now do is go for the big power on. We have fan spin and we have LED. I don't know if you guys can see it. It's down in there. There it is. You can see the red. We have fan spin. So we've got power. What we'll do, we'll get it back together and let's do some proper tests. So let's plug the HDMI in. We'll plug in power. What we'll then do is turn it on, go to the workbench. Boom, you can see we've got something up on the display. And we're into the menus. So we all look good. Okay, I'll finish the reassembly, put it through some proper testing, and I will speak to you at the end of the video. So the repair is all done and the module is working absolutely fine. In fact, that's my one. It's been shipped back to its original owner, and as far as I know, it's working perfectly. Now, this issue, as you saw, was caused by a blown fuse on the input from the DC jack. In the video, you saw me replace that fuse with a larger rating one, which was 12 amp. Don't worry, that is not the fuse we left in the module. That was simply the one I used for testing. I went back after what I've shown you and actually replaced it with a correctly rated fuse, making sure that if there is a problem again in the future, it will blow. Carl recommends a fuse of about 2 amps. I ended up putting one on, I think, just over that, but we ended up using a small jump wire as well because I only had a smaller SMD component, but it's all good, it's all working, and it's in the hands of its happy user. Now, as for what was the cause of the fuse blowing, well, there was no short on the inside of the module. My belief, though, is that this is caused by users not using the original BEC power cable. The original cable for the SharkBite VRX module has a BEC installed in this area here, which outputs about 7.8 volts. You can, though, run this module directly on battery up to 4S. My belief is the cause of the failure is inrush current as a result of there being no restriction when using it directly to battery. When on this BEC, it simply can only provide the current that the BEC is capable of. However, when you're using a direct battery connection, there is no limit and it will simply take as much current as it can as it fires up. And I think that's the reason for the fuse blowing. So, how to avoid this? Well, my personal belief is you should always use the BEC power cable, but if you're not using one of them, I would advise powering up your goggles first before powering up the VRX module, and then power it up carefully, making sure that you're putting the cable in nice and quickly, no sparking, no arcing, and it should be fine. But if you are having issues where your module goes completely dead, that fuse would be the first place I would take a look. Now, I have uploaded all the information on this repair, including images on all of the HDZero gear I've got and repair info as well, onto repair.wiki. If you don't know what repair.wiki is, it is a website that has a huge amount of information for doing repairs on laptops, mobile phones, and I've been slowly uploading lots of information on DJI FPV and HDZero, as well as putting repair information up there as well. I'll put a link to the VRX page on the description of this video if you want to check it out, and there's more info up there as well that I've been uploading, as well as other people has, on the various parts of HDZero, and it's building up nicely to be a really good resource for getting information on not only what's inside these things but also the common faults as well. If you found this video interesting and you would like to support us to continue to make content like this, please do consider checking out the links to my Patreon as well as buy me a coffee in the description. It is only the support from you guys that allows me to be able to keep making content like this, allowing me to be able to spend the time uploading stuff onto repair.wiki as well. So if you'd like to support us to be able to keep doing that, please do check out the links. I want to say a massive thank you to all of my Patreons. I would not be able to do what I do without your support. Anyway, that's it from me. If you found it interesting, if you're not a subscriber, please do hit the subscribe button. Please do give us a like, stay safe, and I will speak to you guys again soon.